Additions reactions of alkene. All alkenes can undergo additions reactions. And additions reactions occurs when the double bond, we know that all alkene has double bond, right? Because it's unsaturated hydrocarbons. So unsaturated hydrocarbon, it has double bond and triple bond. For alkene, it has a double bond. This double bond is one of the bond is quite weak. Okay, so means that we can add something into the double bond. So we convert the double bonds into the single bond, and then we can add in some new atoms into the double bond. This reaction is called additions reactions. Let me show you the example. Okay, so for example, this is an alkene, right? What's the name of this alkene? Ethene. Okay, if ethene react with another molecule called AB. Okay, we don't know what is AB. Okay, but anyway, just let's take examples. Okay, this is AB. Yeah? So this AB can be added into the double bond. We can add this AB into the double bond. So what happened is that this AB, we add this AB into the double bond. After we add the AB into the double bond will become a single bond. The double bond will become a single bond, and the hydrogen is still there. Okay, not affected. Hydrogen is still there. Okay. Now after this double bond becomes single bond, yep, then it will have two bonds, okay, which is free. Yeah? Okay, do not attach to any other things, right? Okay, so these two bonds will attach to A and B. Yeah? So then it will become AB. Yeah? Okay, AB. So this is a new molecule. So this reaction is called additions reaction. We add this molecule AB into the double bond of alkene. Then we have a new molecule. This is a new molecule. So this reaction is called the additions reactions. Actually, we can add a few substances into the double bond, which we will discuss later. For example, we can add hydrogens. We can add halogens like bromine, chlorine into this double bond. So all of this reaction is called the additions reactions. So this is the ideas of the additions reactions. The first additions reactions that we are going to discuss is called hydrogenation. Hydrogenation. From the name, and then we can know that this is a reactions where we add hydrogens. We add hydrogens into alkene. Okay, because it's a hydrogenation, right? Hydrogen. So hydrogenation is the reactions where we add hydrogen into alkene. Now hydrogenation is additions reactions. This is additions reactions. This is one of the additions reactions. For examples, let's say ethene. Okay, this is ethene. If it's react with hydrogens, so what happened is that this hydrogen is added into the double bond, right? Then it will become something like this. So the two hydrogen is added here. So then this is a new molecule. What's the name of this new molecule? What's the name of this new molecule? Ethane. Okay, it's an ethane. So this is an ethane. So you see, hydrogenation is a reactions that change alkene back to alkane. This is alkene. This is alkane. So through hydrogenations, we can change alkene to alkane, or we can change this unsaturated hydrocarbon. This is unsaturated hydrocarbons back to a saturated hydrocarbons. But usually we do not do this. Okay, because alkene is much more valuable compared to alkane. Alkane usually is it can only use as a fuel, but alkene, it has many uses. So usually we do not do this, but this is just let you know that this is one of the additions reactions. Of course, if you do these reactions to propene, so this is a propene, right? Okay, if you do this to propene, then you can get propane, right? If this is a propene, okay, if you add hydrogens, then you will get a propane. You will get a propane. So this is a propane. So this is hydrogenations. Okay, we add hydrogens into alkene. Now this is one of the additions reactions. Now there are a few things that you need to know about these reactions. First, it changed unsaturated hydrocarbon to saturated hydrocarbons. We already know that. Okay. Second, you need to know the conditions for these reactions. Okay, the conditions for this reaction. For examples, this reactions, okay, is under high temperature. Okay, the temperature is about 180 degrees Celsius. So this is the temperature of the reactions. Okay, and then you need a catalyst. So the catalyst that we use is nickel, Ni. This is nickel. So we use nickel as the catalyst. Okay, nickel as the catalyst. This process is used to produce margarine. We will discuss this later. Okay, the productions of margarine. That is the last part of this chapter, where we discuss lipids, fat. At the times we will discuss how this hydrogenation reaction is used to produce margarine from oil, like coconut oil, palm oil. So we use these hydrogenation reactions to change these palm oils to margarines. We'll discuss that later. Okay, so you need to know, you need to know the conditions, the catalyst used, and the temperature. You must remember this or memorize this, and you need to know the use of these reactions as well. These hydrogenations. That's what you need to know about hydrogenations. Another things that we can add into this alkene is hydrogen halide. I mean, what's halide? Some examples of halide. Halogens. For examples, fluorine, right? Fluorine, chlorine, bromine, iodine, right? Okay, so these are halogens, right? Halogens. Now, if these halogens become ions, then we call it halide. For example, fluorines, when they become ion, it becomes fluoride. Chloride, bromide, and iodide. So these are halide. Fluoride, chloride, bromide, iodide. These are halide. So fluorines, F2, this is a molecule. Chlorine, Cl2, bromine, Br2, okay, iodine, I2, right? Okay, but if it become ion, this will become F negative. This is fluoride, chloride, bromide, iodide, I negative. So these are halide. Now then, what is hydrogen halide? What is hydrogen halide? So examples of hydrogen halide is HCl. Okay, this is called hydrogen chloride. Okay, hydrogen chloride. HBr, hydrogen bromide. And so on. Or HI, hydrogen iodide. So these are hydrogen halide. So for halide and hydrogen halide, should be no problems, right? We can add hydrogen halide into alkene. For example, ethene. Let's say ethene. We have an ethene, and then this ethene, it can react with HCl. Okay, hydrogen halide or hydrogen chloride. So this HCl can be added into the double bond, right? So then it will become something like this. The hydrogen is still there. Then this halide, H and Cl, will be added into the double bond. So this is a new molecule produced. And the name of this molecule is called chloroethane. Because it becomes saturated, so this is called ethane. Chloroethane. One chlorine, right? One chlorine attached to this ethane. So this is called chloroethane. Let me give you another example. Let's say propene. Propene. So when these propenes react with, let's say, hydrogen bromide, so then we get something like this. You see, this is HBr, right? HBr, okay? So sometimes students will ask, okay, now this Br will attach to the first carbon or the second carbons. This Br, okay? Actually, both also will happen, okay? Sometimes it will attach to the first one, and sometimes it will attach to the second one. So you can either draw it, this bromine, you can either draw it attached to the first carbons or the second carbon. Then it become bromo, because it's bromine, right? Bromo. This is a propane, bromo-propane. Or sometimes we call it 1-bromopropane because this bromine attached to the first carbon. So you need to tell the positions of the bromine. It become 1-bromopropane. But for this one, actually, the naming is not important in our syllabus. Okay, they seldom ask you about the naming of this chloro and bromo alkane. Yep, they seldom ask you this. Okay, so if you are not very good in this, it's okay. Yeah. Okay, so that is the additions of a hydrogen halide into alkene. We can add hydrogen halide. Hydrogen halides include hydrogen fluoride, hydrogen bromide, hydrogen chloride, iodide. So you see, this one actually, the name, okay, it's very close to hydrogenations, right? But this is not hydrogenation. This is called halogenations. Hydrogenation is a process where we add hydrogen into alkene, right? And this is called halogenation. This is a process where we add halogen into alkene. We add halogen into alkene. For example, ethene. Let's say it react with chlorine, okay? Then the products will be this. So this chlorine adds into the double bond, so they become chlorine here. And the name of this molecule is called 1,2-dichloro ethane. 1,2 is because the chlorine attached to the first and second carbon. So 1, 2, okay, dash. Dichloro means there are two chlorine. Dichloro, and ethane is this structure, because this is a saturated hydrocarbons, okay, or saturated alkane. So it's called a dichloroethane. 1,2-dichloro. Another example. Let's say we have this propene. Okay, propene. Sometimes they may give you butene. Okay, but usually I'll use examples of ethene and propene. So we add, let's say bromine. Then the products will be something like this. So the bromine will attach to the first and the second carbon. What's the name of this molecule? It's similar to this one. So 1,2-dibromo propane. Okay, propane. Propane is because we have 3 carbons here. Okay, 1,2-dibromo propane. Now, another thing that you need to know about this reaction is the observations. You need to know that chlorine its color is yellowish green. The chlorine water, okay, or greenish or yellowish green. Okay, greenish or yellowish green. The color, and the colors of this bromine is brown or reddish brown. It's reddish brown or brown. So when this ethane gas, sorry, it's ethene, it's not ethane, it's a mistake here. This is ethene, ethene gas or propene. Ethene or propene gas is bubbled into bromine liquids. The brown or reddish brown colors of the bromine will turn colorless. Why? Because these bromines, the color is reddish brown, okay? But after it become 1,2-dibromopropane, this is colorless. This is colorless. So the reddish brown colors of the bromine will become colorless. This 1,2-dibromopropane is colorless, okay? And so does this chlorine. The chlorines, the liquid chlorines or the chlorine water is a yellow color or a yellowish green, okay? And this color will also become colorless, okay? Because 1,2-dibromoethane is colorless. So means that the alkenes will bleach the colors of halogens. All halogen has color, okay? All halogen has color, and alkene can bleach the colors of the halogens. That is the main difference between alkane and alkene. So we will use this to distinguish alkene from alkane. If you bubble ethane into bromine, nothing change. Yeah? If you bubbles alkane into alkene, okay, you won't see the color change. But if you bubble alkene into bromine, then the colors of the bromine, the reddish brown colors of the bromine, will become colorless. So if you have two gases, alkane and alkene, you don't know which one is alkane and alkene, then you do these experiments. Then we will know. You do these experiments, the one that bleach the colors of the halogen will be alkene. So that is halogenation. We add halogen into alkene. Hydration. This is another addition reactions. From the name, okay, hydration. Hydro means water, right? Hydro means water. So hydrations means we add water. We add water, H2O. We add H2O into alkene. So for example, we have ethene, and then it reacts with a water molecule. Okay, water molecule. But this is not really water. This is steam actually. Steam. Why? Because you see the temperature is at 300 degrees Celsius. 300 degrees Celsius. And we know that water boiled at 100 degrees Celsius, right? So all the water will become steam. This is a water molecule, but it's in the form of steam. What happened is that this water molecule, the water molecule, actually the molecule is HOH, H2O. The water molecule, the structural formula is a HOH. So what happened is that it will break here. Okay, it will break here. And one of the hydrogen's molecule will attach to one of the carbons. So the hydrogens attach to the carbon. And then the OH, this OH will attach to another carbons. OH. Okay, sometimes we draw this OH like this. Or you can draw it this way. You can draw it OH. This is a new molecule form, and this is an alcohol. This is an alcohol. We are going to discuss alcohol in next lessons. Now just let you know that this is an alcohol. Alcohol, the functional group is this, we call it the hydroxyl group, the OH. The carbon compound that has this OH is called alcohol. And the name of this alcohol is called ethanol. Ethanol. So hydrations of alkene will produce alcohol. Okay, so see the note here. Alkene is converted, become alcohol. So this is a process to convert alkene to alcohol. And the water is in the form of steam. Okay, so not really water. Okay, just a water molecule, but not really water. Is in the form of steam. And you need to know. You need to remember or memorize the conditions. For example, the catalyst used is phosphoric acid. Phosphoric acid, and the temperature is 300 degrees Celsius, and the pressure is 60 atm, 60 times of the standard atmospheric pressure. So that's what you need to know. And alcohol can be changed back to alkene through dehydration reaction. If you still remember, last week we discussed the preparations of alkene, right? And one of the reactions is dehydrations of alcohol, right? So dehydrations of alcohol is a process where we take out or we remove a water molecule from alcohol. So you take out water from alcohol, then it become alkene, and you add water into alkene, then it will become alcohol. So it's a reversible process. Alkene, add water, become alcohol. Take out water from alcohol, then it become alkene. So that is hydration's reactions of alkene. Oxidation's reactions. Oxidation's reactions, from the name, you should know that this is a process where we add oxygen. Yeah, we add oxygens into alkene, right? Yeah, add oxygens. But the process is not we add oxygen directly. We have an alkene, okay, and then we add oxygens, then we become a new molecule. No, this is not the case. We do not add oxygen directly. Now, if we do not add oxygen directly, then how we add the oxygens inside? How do we add these oxygens into this molecule? The oxygen is supplied by a chemical called the oxidizing agent. We have a few oxidizing agents. We will discuss this in the next chapters called oxidations and reductions. But for the time being, you just need to remember this oxidizing agent, potassium manganate. Potassium manganate. This potassium manganate is purple in color. The color is purple. You need to remember this. Potassium manganate is purple in color, okay, and it's an oxidizing agent. And this oxidizing agent, it will supply oxygens. It will supply oxygens to alkene. So we do not add oxygen directly. Yeah? Instead, we use an oxidizing agent. The oxidizing agent that we use is a potassium manganate. Okay, and this potassium manganate, it will supply oxygens to the alkene. Okay, so the reactions or the equations of the reactions is like this. Okay, we plus. Okay, we do not plus O2, but we plus a square brackets O close brackets. So if we put a square brackets, okay, with an O inside, means that this oxygen is supplied by oxidizing agent. Supply by oxidizing agents. Just O, no O2, just O. Square brackets O only, not O2. Potassium manganate, the formula is KMnO4. So this is the formula of potassium manganate. But when we write the chemical equations, we do not write this. If we write this, the equation will be very complicated. You are going to learn this when you go to higher levels like A levels or STPM. You're going to learn that. Okay, how to write the oxidations reactions that involve this manganate. But for SPM, because we don't want to confuse you, so we just put a square brackets O to denote that this is the oxygens that come from oxidizing agents. That's all. If we write this, it will be very complicated. If you want to know, you can go to Google to search for this to see how the reactions or how the equations looks like. It's very complicated actually. So this alkene, we plus a square brackets O, okay, and at the same time, so we need water. Yeah? We need water. So remember, we need to plus the oxygen and water, and the products is this. OH. This is a product, and this is an alcohol. This is an alcohol, and we call this a diol. We call this a diol. Diol. Di means two. All this O actually is the to denote the functional group. This OH. This OH. Okay. So diol means we have two OH functional groups attached to this molecule, and the IUPAC name is ethane 1,2 diol. Ethanes 1,2 diol. Now, for the time being, you don't need to worry about this name, okay? This name, because we are going to learn this in next lessons. Next lesson, we are going to discuss alcohol. At the time, we are going to learn how to name alcohol. So you don't need to worry about this. So this is oxidations of alkene. We add oxygen into alkene. Yeah, oxygen into alkene. At the same time, we need the water molecule, but the oxygen is not added directly from an oxygen's molecule. Instead, we use oxidizing agent to supply the oxygens. But when writing the equations, we don't need to write the oxidizing agent. We just put a square bracket O. So potassium manganate is an oxidizing agent. This is the oxidizing agent that we use. Okay, maybe I can write here from KMNO, oxidizing agents. Okay, and the product is a diol. So this is a diol because it has a 2 OH group. This is called a diol, and the IUPAC name is etanes 1,2-diol. Another thing that you need to know is the change of the color. So they will always ask you the change of the color. Potassium manganate, this comes from potassium manganate, right? The color is purple, the purple in color, but the diol is colorless. The diol is colorless. This is colorless, and this is purple in color. So therefore, if we bubble this ethene into this potassium manganate solutions, the purple colors of these potassium manganate solutions will become colorless. So observations: the purple colors of acidified potassium manganate solutions change to colorless. And therefore, this is also another method that we use to distinguish alkane from alkene. If we bubble alkane into potassium manganate, no color change. But if we bubble alkene into this potassium manganate, then the purple colors of this potassium manganate will become